Hello, learners. Today, I shall give you the first lesson on R programming language. To enable you understand better, I will share some screen with you. With the learning objectives. These are the learning objectives of this lesson. I shall discuss the concepts of R environment, basic advantages of R, that is R programming language, R execution system, R character set, R words, data types in R variables, constants, and litters, R operators, statements in R, installation of R as a displayer, R as a disk calculator, objects in R, and finally R as a scripting language. Now, first of all, let me tell you what is R. R was created basically as a scripting language for statistical data manipulation, fast analysis of data, and efficient graphical presentation. R is said to be a scripting language because it is an integrated suite of software environment that provides an interactive runtime platform to execute instructions directly without any compilation. The runtime environment of R is also capable of providing the additional functions, integrating complex systems, and communicating with other programming languages. The incredibly comprehensive package of R can be utilized for big data analytics, machine learning, signal processing, statistical tests, and modeling, state-of-the-art static and dynamic graphical display, data mining, distributed computing, and object-oriented programming, apart from basic mathematical and statistical computations. It is an implementation of the S language, which was developed at AT&T for statistical computations exclusively. R was created by George Ross Lakha and Robert Gentleman under a GNU project at the University of Auckland, New Zealand in 1991, and is currently developed by the R development core team. The term GNU, note that it is pronounced as GNU, stands for a recursive acronym of GNUs, not Unix. The word GNU originates from the alternative name of a wildebeest, which is a large dark antelope with a long head, a beard and mane, and a sloping back, as shown in the figure below. This is a wildebeest called GNU, wildebeest. Why R? Why to use R? R is the best choice of professional statisticians and data scientists because it is both inexpensive as well as beautiful. The following additional features of R lie behind its growing popularity. It is usable in the Windows, Mac, and Linux operating systems, which are used by most of the computer users. Although R was created as a special purpose scripting language for data science and statistical operations, it can also be used as a general purpose programming language like C, Java, etc. for developing any application. The features of both object-oriented and functional programming languages are inbuilt in the language. Since the system saves data sets used between sessions, reloading of data sets is not required. Moreover, the used command history is saved automatically for later use. R can be used both in interactive mode for immediate outputs or on-demand results through interaction with the user, as well as in batch mode for a set of outputs at the end of execution or for periodic run. The basic features of our programming language. We know that any language is a set of characters, words, and syntactic rules used to express ideas for a meaningful communication. There is no exception to this for the R language also. So, we shall study R from this perspective, unlike other textbooks on R. We shall see in steps that R is a very simple, yet beautiful, as well as highly powerful computer programming language. We shall also observe that it can be used like other high-level programming languages for developing user-friendly applications of all types. We shall therefore study the language both as a means of general-purpose program development as well as a platform for specialized arenas of applications like data science. Since every language, be it natural language, human language, or a computer programming language, must have a definite set of symbols called the character set of the language, it is true for R also. So we need to learn that first, the R character set. The term character set implies the set of symbols used in a language or a system of writing or printing. The R character set comprises 88 characters as shown below. These are the characters, the letters of the English alphabet in uppercase form as well as in lowercase form. And they are 52 in number. The digits 0 to 9, they are 10 in number. And the special symbols, comma, semicolon, period, opening parenthesis, closing parenthesis, opening brace, closing brace, opening square bracket, closing square bracket, underscore, percentage, slash, plus, minus, asterisk, less than symbol, greater than symbol, vertical bar, colon, equal to, ampersand, caret, note of exclamation, hash, dollar, and space. They are 26 in number, and total number of characters thus becomes 88. It may be noted that we can use both uppercase and lowercase letters of the English alphabet for defining something in R. However, R is case sensitive. This implies that anything defined by using, say, uppercase letters can never be referenced later by using its lowercase form. We have to insist on uppercase form if it is defined in uppercase letter, and if it is defined in lowercase letter, we have to continue in this. We can also define something in R using mixed case letters, uppercase, lowercase, mixed form. In that case, it should be it has to be used in that form. Words in R. Now, what are words? Being a language, R must consist of words. A word of a language may be defined as a single, distinct, meaningful element of speech or writing. An R word is defined as a consecutive set of characters from its character set that satisfies the following rules. Words in R. Number one, rule number one is this. It can be a combination of letters, digits, period, and underscore. It must start with a letter or a period. If it starts with a period, it cannot be followed by a digit. It can be of any length effectively. It, like any other language, R comprises two kinds of words, namely reserved words and user-defined words. The reserved words of a programming language are the words that act like the building blocks of the language, each having a definite application with a particular syntax and semantics. By the term syntax, we mean the set of rules that defines the arrangement of words or symbols in a language. On the other hand, the term semantics means the meaning implied by words, phrases, and sentences of a language. For instance, the rock smelled the color 5 is a syntactically correct sentence, but it has absolutely no meaning because rocks do not smell, and even they couldn't smell a color that doesn't exist. Now, reserved words. What are reserved words? Reserved words of natural languages are the words found in the dictionaries of the languages. Most of the reserved words in R have been formed with lowercase letters of the character set. The reserved words cannot be used for any other purposes except for the purposes for which they have been defined. The user-defined words are the products of human mind, which are used to assign a name to any user-defined entity to be used in the R environment. Some examples of user-defined words may be name of a person, name of a memory location in the computer, etc. Variables and identifiers in R. A variable is a named location in the main memory of a computer being used, which is defined for storing data according to the need of a user. As the value stored in such a location may change, that is vary, it is popularly known as a variable. Variables having unique names are known as identifiers, since they identify a specific location in the main memory without any ambiguity. Thus, the combination of characters, salary, these were amount paid, amount dot paid, dot value are valid identifiers, whereas TRUE, true, in uppercase form, being a reserved word in R. Now, dot one salary violates the second rule of forming R words. Underscore name violates the second rule of forming R words. 1, 2, 3 violates the second rule, etc. Invalid variables or identifiers. Best practices to form compound user-defined words. Since the earlier version of R used underscore as an assignment operator, hence the period, that is the dot or full stop, what we say commonly, was used extensively in variable names having multiple words. Current versions of R support underscore as a valid character in an identifier, but it is a good practice to use period as word separators to avoid confusion in using programs in earlier versions. For example, a dot variable dot name is preferred over a underscore variable underscore name, or alternatively, we could use camel case in a variable name, such as monthly salary, where AM is in uppercase, S is in uppercase, and the rest are in lowercase. Such case structure is called camel case. R constants. What are R constants? R constants are the entities, the values of which remain unaltered under all circumstances. R constants are basically of two types, namely system-defined constants and user-defined constants. The system-defined constants are some reserved R words, denoting some frequently required values, such as the value of the mathematical constant pi. You know this symbol pi. The value of this constant can be obtained by writing pi only. Similarly, we use the word letters in uppercase form, letters, to have the letters of the English alphabet in uppercase form. R constants. The word letters in lowercase form is used to have the letters of the English alphabet in lowercase form. Month.name, to have the names of the Julian months in full forms from January, February, etc. up to December. Month.abb, to have the names of the months in abbreviated form, as seen in most of the calendars. These are some of the many system-defined constants. So the system-defined constants can be thought of as the constants built into the system, like letters, month.name, month.abb, etc. The user-defined constants are the ones which the users may require to define to serve some specific purpose, such as writing a formula, creating a prompt for the user, etc. There are basically two kinds of these are basically of two kinds, namely numeric constants and character constants. A numeric constant is any number consisting of any numeric data, whereas a character constant is any sequence of characters written by the user enclosed within double or single quotation size. So in the formula, 2 pi r, 2 star pi star r, the number 2 is a numeric constant, pi is a system-defined constant, and r is an identifier containing some value entered by the user. And welcome to R programming within double quotes, or enter any whole number within single quotes, or anything that we write within double quotes like this one. A is note of exclamation, etc., this, whatever it is. Followed by a single quote and followed by the double quotes. Single quote is part of the string that characters that we have written here. Okay, so it is it starts with the double quotes, ends with the double quotes, etc. These are character constants, user-defined character constants in R. Now, R operators. What is an operator? An operator in R is a special symbol or a collection of special symbols that signifies a task to be performed on values specified through variables, constants, or any expression, and tells the computer to perform that task when used by following the grammatical rule of the language. The task is called an operation. The task that an operator performs is called an operation, and the values on which the operation is performed are called operands. So operator, operand, and operands, these are the terms important here. If an operator operates on a single operand, then it is called a unary operator. If it operates on two operands at a time, then it is called a binary operator. If it operates on three operands at a time, then it is called a ternary operator, and so on. The operations can be assignment, arithmetic, logical, or bitwise logical. Depending on the nature of operations, the operators can be classified into the following categories. What are the categories? Arithmetic operators, number 1. Number 2, relational operators. Number 3, logical operators. And number 4, assignment operators. Now, we now discuss R arithmetic operators, which are used to accomplish arithmetic operations on two operands of same data type. Assuming that the identifiers A and B are of same data type, we illustrate the use of the arithmetic operators and their functionalities in the following table. You see, plus operator, its purpose is to add two operands, that is, let's say, A plus B, where A and B are operands, minus subtraction of second operand from first, A minus B. Star asterisk is used for as multiplication operator. It is used for multiplication of two operands, like the in this example, A star B. Slash, division of first operand with second, A divided by B. A is the dividend and B is the divisor. And then comes double percentage sign. Now we call it a modulo operator. It returns the remainder of first operand divided by the second, A modulo B, we can call it. Percent slash percent, it is used for obtaining integer quotient of the division. So A percent slash percent B will return the result of integer division. For example, 5 by 2, 5, this operator, percent slash percent operator, B, that is 2. In place of B, we can place 2. Then it will return 2. And then comes caret operator. This is the first operand. This is for the exponentiation purpose. It is called exponentiation operator. It raises the first operand to the power of the second. So A caret B, A returns A raised to the power B. The value of A raised to the power B. Then comes relational operators. Our relational operators are those that find out relationship between the two operands provided to them. Following are the 6 relational operators operations are programming language supports, the output is Boolean, that is true or false for all the relational operators in our programming language. These are less than operator, greater than operator, equality operator, double equal to. It checks whether the first operand is equal to the second operand. Less than operator, where it checks whether the first operand is less than that of the second operand. The greater than operator, it checks whether the first operand is greater than that of the value of the second operand. Less than equals to, it checks whether the first operand is less than or equal to the second operand. We write in this way, A less than equals to B. And greater than equals to, it checks whether the first operand is greater than or equal to the second operand. We write it in this way, A greater than equals to B. Not equal to, a note of exclamation followed by equal to sign. It is used for not for checking not non-equality. It checks whether the first is the first operand not equal to second operand. We write in this way, A not equals to B. Then comes our logical operators. They work only for the basic data types, logical, numeric, and complex and vectors. The following table depicts the logical operators with illustration of its use case. Ampersand, element-wise logical operator. What is element-wise? What is operand-wise? That I shall discuss later. A is an operand that may consist of multiple values. Then B may also be an operand consisting of multiple values. When we use this A % B, then each value of A is compared with each value of B. That is why it is called element-wise operation, logical operation. Similarly, is the case of element-wise logical OR operation, A or B. Similarly, element-wise logical NOT operation, A not B. Then double ampersand, this is for actually operand-wise logical operation, AND operation, A double ampersand B, that is the value for all the values of A are considered together. That is the first value actually in A, if A contains multiple values, and first value of B, if B contains multiple values, should be considered. This is the operand-wise logical operator. Similar is the case here, double bar, that is, it is the operand-wise logical operator or operator, A or. Then bit-wise logical operators in R are these ones. Operator bit WOR. Note that O is in uppercase, and it is bitwise. It is used for bitwise ORing, or bitwise. It is also called bitwise OR operator. It is written in this way: bit WOR, value 1, value 2. Bit W XOR, bitwise XOR operator, or XOR operator. Bit W not, bitwise not operator. Bit W AND, where A is capital. Note this. Bitwise AND operator, bit W AND, value 1, value 2. Bit W shift tail, it is used for left shift operation. Bit W left shift tail, bit W shift R, right shift. This is called right shift operator. It is used in this way. All operators in logical, all these bitwise logical operators are used in the same form as shown here. Next comes assignment operator. Our assignment operators are those that help in assigning or storing a value to a variable or an identifier. The following table depicts the assignment allowed operators with illustration as its illustration of its use ways. Equality, sign of equality. It assigns right side value to left side operand, like this one, A equals to 5. Then we can use this operator also, less than symbol followed by a hyphen. It also assigns the right side value to the left side operand. We can write in this way: A assignment operator less than hyphen 7. Then 7 will be stored against A. And this assignment operator, hyphen followed by greater than sign, assigns left side value to right side operand. So we can write in this way: 9 will be assigned to A here. Note this. And double less than sign followed by hyphen assigns right side value to left side operand, like this one, A, double less than sign followed by hyphen 9.5. So 9.5 will be stored in A. This operator, hyphen followed by double greater than sign, it assigns left side value to right side operand. So 1 dot dot 5, that means what? 1 to 5, all integers from 1 to 5 will be stored in A. Hyphen is missing, of course, however, but hyphen is to be used here. Precedence and associativity of different operators in R. The term precedence defines the order of execution, that is, which operator gets higher priority compared with other associated operators during execution in R environment. For example, in the expression A minus B star C, the multiplication operator gets higher priority compared to the subtraction operator. This means that here the multiplication operation will be done first, A star C, B star C will be done first. The product will then be subtracted from A. So we say that star operator has higher precedence than subtraction operator. That is star, that is multiplication operator. The multiplication operation will precede the subtraction operation in the evaluation of the value of the expression here. We see. So for this reason, we say that star operator has a higher precedence than the minus operator. The term associativity is related to an operator. In programming languages, it implies a property that determines how operators of the same precedence are grouped in the absence of parentheses. In case an operand is both preceded and followed by operators, for example, star A star, studies case studies, and those operators are of equal precedence, then the operand may be used as input to two different operations. That is, two operations indicated by the two operators. The choice of operation applicable to the operand is determined by the associativity of the operators. Operators may be associative, meaning operations can be grouped arbitrarily, that is in any order. Left associative, meaning the operations are grouped from the left. Right associative, meaning the operations are grouped from the right. Or non-associative, meaning operations cannot be changed, often because the output type is incompatible with the input types. The associativity and precedence of an operator is a part of the definition of a programming language. Different programming languages may have different associativity and precedence for the same type of operator. Let us consider the expression, this x. I have used this tilde sign. Tilde sign is actually used for any recognized operator here. In play, it will be replaced by any recognized operator. So x tilde sign, tilde operator followed by y, tilde operator followed by z. So this denotes any recognized operator. If the operator tilde has left associativity, this expression would be interpreted as this x tilde y tilde z. If the operator has right associativity, the expression will be interpreted as x tilde within parentheses y tilde z. If the operator is non-associative, the expression might be a syntax error, or it might have some special meaning. Some mathematical operators have inherent associativity. For example, subtraction and division, as used in conventional mathematical notation, are inherently left associative. Addition and multiplication, by contrast, are both left and right associative. So x minus minus z will be left associative. In this sense, we can obtain x minus y first, then we can subtract z from that. But x minus y minus z is not equals to x minus y, y minus z, except in few special cases. The following table shows precedence and associativity of operators in R. Exponential operator, right to left. This My unary operator, unary minus, unary plus, left to right. Modulo operator, modulo sub modulo operator, left to right. Asterisk slash multiplication operator, left to right. Plus minus addition, subtraction, left to right. Less than, greater than, equal to, greater than equals to, less than equals to, or not equals to, logical or Boolean operators for comparisons, left to right. Not equal to operator, logical not operator, left to right. Ampersand or double ampersand, single ampersand or double ampersand, logical and logical or logical not, all these left to right. And the assignment operators, these hyphen followed by right arrow or double right arrow, whatever it is, right word assignment, and hyphen less than sign followed by hyphen, double arrow, what we form with less than sign followed by hyphen. It is also left word assignment, right to left. The difference between ampersand and double ampersand should be noted carefully. The shorter one is used to perform element-wise comparisons like arithmetic operators, while the longer form evaluates from left to right, examining only the first element of each vector. I will introduce you to vector later, but right now I have told you that an identifier like A may consist of a single value, or it may contain multiple values. When it contains multiple values in a single variable or under a single name, then the values, and then all the values are called elements. And then element-wise, for element-wise comparison, we use single ampersand or single particle sign for ANDing or ORing, and double ampersand only to compare with the first value of both. The longer form is appropriate in control flow statements, particularly with if clauses. Again, I've already explained this: vertical bar, single vertical bar, double vertical bar. The shorter one is used to perform element-wise comparison, and double bar is used for comparing the whole value. Longer form, from left to right, examining only the first. Next, I shall come to this point: installation for getting R in a working system. R is freely available from the comprehensive R archive network called CRAN, and at http://cran.rproject.org. So if you click at this website, if you open this website, pre-compiled binary distributions of the base system and contributed packages are shown available for Linux in Debian, Fedora, Red Hat, or Ubuntu form, and Mac OS X and Windows. The desired link among the ones shown here is to be clicked for downloading the application environment. The directions for the installation of the base product of the target platform of the system are then followed to get the software in the actionable form. Starting R in a computer. On a Linux or Mac system, R is started by typing R on the command line in a terminal window. On a Windows system, R is started by clicking the R icon on the desktop. The result is a greeting and the R prompt with the greater than sign, the screen display. Let me show you the screen display if we click on R icon on the desktop in my Windows system. This is the R icon. So I click on this. It is being loaded, you see. GUI, graphical user interface of 64-bit. This is called R console. You see, here the version details are shown, and here the prompt with the greater than sign symbol. This is the cursor where we can write something like this that I told you earlier, say letters in uppercase form. If I write this, You see the letters of the English alphabet in uppercase form, letters in lowercase form. Say, see letters, all letters in lowercase form. Month dot name. You see month names are here. Julian month names. Month dot ABV. You see month names in an abbreviated form. Let us go back to our screen. This is the shared screen. You see, when our loads in interactive mode, it shows this GU64-bit, and this is the main menu here: file, edit, view, miscellaneous MISC packages that are available in this system, Windows, help, etc. These are the things. And it shows this type of messages, and this is the prompt where we can type in command. So this is called R console. What we have seen, this is the R console. We can now start working with R interactively, as I have already shown you. Working with R interactively, it is the best way to learn its syntax and semantics. We assume that the user possesses the basic operating concepts of a computer with the fundamentals of operating systems. One can start on Linux system. I've already told you this thing, and the prompt here also the prompt is this. Now I shall discuss statements in R. What are R statements? A syntactically valid combination of R words and other characters forms an R statement. An R statement can also be called an R command, which is basically an instruction for execution. An R instruction is meant for some desired action. We can type a command at the R prompt and press enter to get it executed. The R interpreter translates and executes the command immediately. In case of any error in the command, it shows R error messages that can be understood easily. If desired, we can also change the default prompt of R with a command as illustrated below. We have to write these options. Prompt equals to whatever prompt we want, then it will show this. For example, let me write this. OPTIONS, options. Options. Then what to write? Options within bracket, prompt equals to what prompt do we need? PROMPT, prompt equals to, say, let us write this. Here is R. Here is R. After that, it should show greater than sign. Okay. So let us press enter. Now you see our prompt has been changed. Here is R. So we can change the prompt, our prompt in this way. Okay. So here I have shown it, shown you to change it to R only, R followed by greater than sign. If we use nothing within prompt, then it will generate an error. So within double quotes, prompt equals to, within double quotes, you have to write something, not space. Invalid value for prompt. It is not space or nothing we have written. If we like to save all our works in the R environment in a separate directory, then we can create a new directory, say R programs, under the current working directory, and then move to the new directory under the current working directory. We can check the current working directory by using the function getWD as shown here. GetWD, it shows the current working directory in my system here, getWD. Get work. WD stands for working directory. For example, get WD bracket. You see, this is the current working directory here. We can set our new working directory in this way. Next, if we type the following, press enter, set working directory to our programs, the new working directory will be set to the desired ones. We can check it by the return value of get WD function as this. You see, our programs now have been added to the current working directory that was earlier. So get WD, it shows these our programs. We can also go back to the previous level directory by typing the command set WD within bracket and within quotes dot, as you have seen in DOS. Now, assignment statement. What are assignment statements? The term assignment statements in R implies the statements for storing some data value in an R identifier or variable. To store a value in a variable, we need an assignment operator. As stated earlier, the formal assignment operator in R is arrow sign, actually, which is formed by typing the less than sign followed by a hyphen. A left arrow sign, this formed with less than operator followed by a hyphen. However, the sign of equality can also be used without any loss of generality, as illustrated below. This x arrow sign 5 and x equals to 5 will imply the same. However, an assignment can also be done by using the greater than sign, and shall has to be done in the opposite direction as shown below. 5 hyphen greater than x is also okay. We can see the assigned value by writing just the variable name at the R prompt as shown below. X. If we type the variable name x and press enter, it will show this. Let me show you in R prompt. Say x equals to 7. So it will show, if we just type x and press enter, it will show the value 7. But if we write 5 equals to x, then the following error message will be generated by the system. Error in 5 equals to in x. That is, this is not a valid assignment. Invalid do set left-hand side to assignment. That is, whenever we are writing the equal to sign, the location where you want to store the value must be in the left-hand side. Z equals to 6. This is okay. So if we can also write this, use this hash symbol to write some comment. This is to display the content of Z, for example. So Z, we have stored 6 to Z, and we can see the content of Z by typing Z at the prompt R prompt. T equals to 2, 2 is this 2, TRUE, all in uppercase, is a logical value, and in R, all should be in uppercase. And this logical value has been assigned to the location name T, called variable name of identifier. If we type T, it will show true. B2:9. This implies what? Store the values 2 to 9, sequential values 2 to 9 in B. This is how a number of values can be stored there. If we type B and press enter, it will show the values stored there, separated by space. Let me show you this thing. Say B equals to 1:8, for example. So now let us write B. It will show all the values followed by separated by space. This is the okay, next, let us write this y equals to welcome to R. Some text, we assign some text to some location y. This shows if we write y, then it will show this text, welcome to R. Let us now examine special function in R. which is very often required in assignment of data values in an R variable. It is sec function. It is actually, this function comes from sequence word, from the word sequence, the sequence function. Here in sequence function, we write sequence followed by open parenthesis, from equals to 1 to equals to 1, by equals to 2 minus from length dot divide by length dot out minus 1. That means length dot out means what? How many values you want in between from and to. Okay, so in that way, if we write this from -6 to 7, we have not written any by in that case sequential values will be taken. Sequentially generated integers will be taken into considerations. So -6 to 7 will be shown as in this case. If we write by -6, 7, by equals to this, yes, the values will be increased by 2. We can also use the step value. Let me show you with some step. Suppose using sequence from 5 to 10, I want 10 values. Between 5 to 10, there are actually 5 integers. I want 10 values. So what will be the by value? How can I decide it? It can be calculated in this way. 10 minus 5, 2 minus from, that is 5, divided by how many values I want? 10 values. So that is to be divided by 10 by 9. Length dot out minus 1. That is 10 by 9. That is by. This is by. What happens? From 5 by step. So step can be, by step can be mentioned, length of the sequence. What will be the length of the sequence? I want the length of the sequence to be, I wanted it 5, I wanted it 9. Length of the sequence, length dot out, 2 minus from, 9 minus 1. What was it? Oh, I see. I'm sorry. There was a mistake here. That is what? Sequence starting value is 5, comma, end value is 10, comma, from 2 minus from, 2 means 10, minus from, that is 5. So it should be 5 here, and 5 divided by 9. And you see, I wanted 10 values, so 10 values are shown. That is the thing. I think it is now understandable. So here this value, the numerator or the dividend should be what? The last value minus first value divided by what? The number of values that we want in the sequence minus 1. If we want 10 values, it will be this. If we want, say, 20 values, the sequence 20 values in between 5 and 10. 5, 10, the difference in between 5 and 10 is 5 slash I want 20 values. 20 minus 1, that is 19. Then 20 values will come. So this is how we can generate a sequence of values. Let us see as a displayer, it shows something. If we write A plus B at the prompt with A in quotes plus B in quotes, it will generate an error. But if we write some value, number, say 3, it will show the value. S within quotes as a string, it will show it. And if we write any variable where we have stored something, it will show the values. If we write anything within quotes, single quotes, within single quotes or a pair of double quotes, not an issue, it will show it. I have already shown you month.names or month.name. Month.names will be erroneous. Month.name must be written. I have shown it. And letters I have shown it. We shall see all these things by using our constants. If we write pi, it will show the value of pi up to 6 decimal characters. 6 decimal digits, we can say. Then another point, numbers preceded by 0x are recognized by R as hexadecimal numbers. If we type such a number in the R prompt, then R shows the decimal equivalent of the number, say x20, trying to show the decimal value of the hexadecimal number in a wrong way. So it will generate x20 not found. If we write 0x20, it will show 20. This is the hexadecimal 20 and its equivalent decimal value is 32. And if we write this 0x AFD, again the wrong way. So what to write? We have to write in this way. 0, this is not O. These letters must be in uppercase. Letters must be in uppercase actually. X is in lowercase. So we have to write it in uppercase. So in that case, it will show this. And if we write as dot Roman of some number, decimal number, it will show the Roman form. As dot numeric of as dot Roman this, it will show the numeric value, decimal of that Roman number. R is a desk calculator. We can use R to work just like a desk calculator to perform calculations like this 5 plus 3 semicolon 5 plus 3 this like this way. Okay, so it will result if we write if we separate 2 statements with a semicolon in between, then both the statements will be executed and the outputs will be shown one after another. Or we can also write only one expression like this to get the result. This is multiplication operation, division operation, modulo operation, exponential operation, not an issue. So all these things, this is also modulo operation. This is the integer division operation, percent slash percent. We can also perform this, it will return the value as usual. SQRT is an R function, built-in function. We can get the square root of that. Log of within bracket, log to the base E will be obtained. Log 3, log 2 in this way. Factorial value can also be obtained in this way. And thus R can be used as a calculator, this calculator. Objects in R. Every entity in R with which we deal is called an object. Thus, a variable or identifier that we create to work with is also an object. R supports 6 basic classes of objects as stated below. Character, numeric or real numbers, integer, whole numbers, complex imaginary numbers, logical, true, false, Then comes the raw. Objects of any of these classes are known as atomic structure, meaning that components of that object are of same type or more. The term more implies the basic type of the fundamental constituents of the object. Objects of character class may contain any set of values enclosed within single or double quotes. So such values cannot be used for arithmetic calculation. Objects of numeric class can be any number with or without decimal part. Objects of integer class can be obtained by storing any numeric value in an identifier using as.integer function as illustrated below. Say as.integer 5i. Say class of I is integer, but the mode of I will be numeric. If we ask mode of I, it will show numeric. Objects of complex class are created by storing a complex number in an identifier. We know that complex numbers are of the form x plus yi, where x and y are any real numbers including 0. Here are some illustrations. Z equals to 2 plus 3i, t equals to 5 plus 0i, b equals to minus 1 plus 0i, etc. And our object becomes a logical one if we store either t, capital T, or uppercase T, or 2 in uppercase form, or f in as f for false in uppercase form or false with uppercase letters value in it as illustrated below. X equals to 2 as not logical, we can check it is 2. Similarly, if x equals to false, we can check x dot logical to get false value. The raw data type is meant for obtaining the hexadecimal value of a number, of a decimal number. Say a equals to 16, s dot raw will give us this value. Decimal value, equivalent decimal value is 10. Hexadecimal value, 16 is the decimal value, and the given value under s dot raw will be the hexadecimal value. So 10 is the hexadecimal value of decimal 16. Apart from these data types, R supports another data type called double for integer arithmetic of higher precision. Numbers of double type are double precision numbers. The additional bits in storage not only increase the accuracy in the calculated value, but also the range of magnitude that can be represented. The use of double is illustrated below. S equals to double, S equals to 6, S, if we print the content of S, it will show this 6. Y, double up to Y, it will show this. Our constants can be checked with type of function. Numbers are stored in double precision format by default. For integer constants, numbers must be followed by capital L, not small l. And complex constants, the numbers must be followed by I. Use of that function is illustrated below. Type of 7, double. Type of 7L, integer. Type of 7I, complex. Type of letters, character. Type of Ramdhanu within double quotes, character. Type of 1, 2, 3, 4, 5 within single quotes, character. Double quotes and single quotes have got the same meaning. The outcome of going through this lesson is knowledge of the following concepts that you must have attained. History of the R language, different platforms that R support, the R character set, words, variables, identifiers, and constants in R, operators in R, precedence and associativity in R, statements or commands in R as a displayer, R as a disk calculator, R as a scripting language for data manipulation, objects in R.